Hi, my name's Tom Cutter. Thanks for taking the time to watch this video. Today I'd like to talk about the project I recently completed, my HNC in Electrical Engineering. The project was entitled PLC-based box sorting system. I'll just explain now a bit about what exactly that is. What I wanted to do was produce a miniature mock-up of a classic industrial process. And what we got here is conveyor belt, sensors, actuators, control panel and a PLC. And what this particular process demonstrates is the sorting of these boxes depending on their colour and height into an appropriate storage bin. So for instance, if you put a blue box on the conveyor, it'll move its way along the conveyor, the sensors will pick up the type of box it is, and then the appropriate actuator will operate, in this case this 12 volt armature here. As it moves down, it will push that box into the blue bin. Same with the red, which will end up in there. The same with the black, which is the reject size, which would miss all the actuators and end up in the bin there. So like I said, I just wanted to really try and recreate all the components of an industrial process, but in like a miniature version. So we've got actuators, sensors, relays, PLC, loading area here, which contains the sensors, lots of indicators to tell you what's going on. And of course the PLC itself, which is in the control panel, which we'll come on to in a minute, which controls the whole system, which I completely programmed myself from scratch to get the system working exactly how I wanted. There's some safety features and some little features added in there as well. So overall I was really happy with the results. So just to talk a little bit more about the build, like I said, I designed it all from scratch, bought all the components myself, put it all together myself, just from nothing really, and to the result, what we see in front of us here. The only help I had was a local fabricator, maybe the frame to hold everything in, but on my specification. So that's a bit about the actual project and the build itself really. Now I just want to have a little look at the control panel, which is the hub of the system. As you can see, it's a classic sort of industrial panel setup. Isolator, control buttons there, start and stop, e-stop, some reset buttons there which you use for various things, which is these ones actually when the bins get full, once you've emptied them, you come and reset. And then you've got various indicators there. I was quite keen on having lots of indicators to tell the user exactly what's going on. So for instance, system's running, conveyor's running. If the e-stop's operated, you get a nice red indicator there, and that's what's going on with the bin. So if they're full, you have a light to tell the operator what's going on. Right, so let's have a little look inside the control panel now. And there we are. I'll just shine the torch because it can be a little bit dim. So there we are. So in there you've got a classic control panel setup, relays down the bottom, connectors at the top, the isolator arms there. There's all the wiring for the indicators there, and there's the PLC that I talked about. I used a Siemens logo, which was a nice little model which was perfect for this kind of smaller installation. Got a power supply there, there's the computer itself, and there's some expansion modules I had to use. As I went along I realised I didn't have enough inputs and outputs on the main module, and then I realised I didn't have enough on them, so I ended up actually buying quite a few expansion modules. But that, like I said, that's the hub of the operation. I wrote the program myself, and that basically takes the inputs from the sensors, the buttons, all the stuff like that, and then according to the program it will then tell the outputs what to do, which is your motors, indicators, your actuators and all the things like that. So that's the control panel. So now let's have a little look at the system actually running. I'll press the start button on the control panel there, get a flashing light say this conveyor's in standby, and then the beacon, the miniature beacon sounds to warn people who are using the machinery that it's about to start. Now, let's just see what happens. The red, like I said, the red should end up in the red box, blue in the blue box, and black should go all the way to the end as the reject. So let's put a red box on and see what happens. As I was saying earlier, there's a loading area here, and what we got here, if you just have a quick look, there's a green light there for OK to load, and a red light which tells you don't load. So that gives the user an idea of when they should be loading. That's to prevent a backlog, to prevent people chucking too much stuff on while there's still actuators working and things like that. As you can see, the blue box has ended up in the blue. Now hopefully the black box is the reject size. That doesn't want to end up in any of these bins, it wants to go straight into the reject bin on the end. So put that on the conveyor and that runs down. A little bit about some of the components: 24 volt motor, and we've got 12 volt actuators. When I got them, I actually realised that they see the black reject ended up in the black bin. When I got them, I realised that they only had one red and one black wire, and so you had to actually, so they'd only go one way, so I actually had to find a way of reversing the polarity to drag it back like you're seeing there. So I had to do a little bit of messing around, but that's all in the control panel and that's all working fine. And all the timings, all this is all worked out on the PLC. One thing I wanted to avoid was the bins getting too full and having, like I said, having backlogs on the system. So a little feature I put in was a counter on the PLC which would work out when too many boxes have ended up in the bin and it's full. This is something which you'll see should happen now. The system picks it up and it stops the conveyor, so therefore that bin can't get any more full. Now in a proper industrial process, what could happen here, a signal could be sent to a control room. They could tell a forklift driver to come down and empty the bin, or other ideas could be you could have a full bin there, an empty bin there. It could automatically twist around, but obviously, you know, at some point I had to decide how far I wanted to go, and I thought, well, what we'll do, we'll have a light on the control panel which tells you the bin's full and the conveyor will stop. So what the user has to do, empty the bin, press the reset, say right, I've emptied the bin there, press the reset, remove the box off the conveyor, and then the system can start up again. And away we go. We're back to normal. So that's the basic operation of the system. Just to have another look now at the control panel, some of the features on here. Start button, stop button, so if I want to stop the conveyor there, start it up again, press the start button. And safety wise, the main feature we've got really is the e-stop here. If I press the e-stop, the system comes to a halt and we get a nice red light there. So that's the basic working of the system. It's all up and running, and I'm very happy with it. And as you can see, there's some important safety features as well. So if we isolate the system, and there you go. Hope you enjoyed the video. Cheers.